Welcome to chapter 2. So we're going to start out nice and easy. Basically, we're going to take numbers, like 7, 2, 21, and we're going to categorize them. Negative 50, 3 fourths, 0.761, 3, 6, 9, 52, 1, 0, 5. Okay, we're going to categorize these numbers. It's basically all we're doing today. You've got two types of numbers in the world. Real numbers and imaginary numbers. Every number you've ever known up to this point has probably most likely been real. So we're going to look at our real numbers today and we're going to categorize them. So first of all, if you start with a real number, it can break apart into two separate categories, which are these two bubbles right here. So we're going to first branch off to this one. Let's say you let a friend borrow your favorite video game system, and they return it to you broken because they got upset and they threw it out the window and it fell apart. You could react in one of two ways. You could be like, wow, I'm really upset with you, but please just replace it and we can move forward. Okay, that's one way. The other way, you might be like, oh, okay, that's the second way you might react. One way was while the other was very, okay? So the word I'm trying to gather from you is rational, which was the calm, okay, response, versus irrational, where you're just like going crazy, okay? So when you think about numbers like that, our rational numbers are the ones that we're used to seeing. 5, -7, even 1/2, that's very rational. But our irrational numbers are the numbers that just like, what are you doing? So the most famous irrational number is pi, okay? When you think of pi, what comes to mind? Like the number, not the food, okay? 3.14159267469. I'm just yelling out numbers now. I don't know it that far, okay? But pi, it's a decimal that goes on forever. It's very irrational. So those are two categories. First one, being right here, we're going to talk about rational numbers. The root word of rational is ratio, okay? Meaning a comparison of this to that. If a number can be written as a ratio, it's a rational number. So examples of that would be like fractions. 2/3, okay, it's written as a ratio. If you have the decimal, 0.6 repeating, that decimal, even though it's a repeating decimal, it can still be written as a fraction. 0.6 repeating is 2/3. So 0.6 repeating and 2/3 are both rational numbers. And then you also have your negatives, your positive numbers, and 0. So your rational numbers includes the group of numbers that are your positives, your negatives, your fractions, repeating decimals, actually, the reason that I've got this fellow right here on your notes, anybody know who that is? Does anybody know? Yeah? That is Arnold Schwarzenegger playing the Terminator, okay? What does it mean to terminate something? What does he do? He ends lives, okay? So a terminating decimal, that's another one. A decimal that stops. So a decimal like 0.75, it terminates, it stops. 0.75, that's it. So this list is going to include terminating decimals, decimals that stop, and repeating decimals, kind of like I said before, the 0.6 repeating. And then, of course, can't forget 0, okay? So this is your list of all rational numbers. I'm going to give you a few examples. 7/9, we said 0.75, 0.6 repeating, 4, -7, 0, okay? Those are all rational numbers. The other option for your real number, so it could be rational or it could be irrational. This list is a lot smaller. So if it's not a decimal that stops, like pi, the decimal that goes on forever, it's what we call a non-terminating decimal. So it goes on forever. I'm going to add that there, decimals that go on forever. And your example, again, would be pi. Also, numbers like the square root of 2, the square root of 5, the square root of 10, square roots. If the number underneath the radical sign is not a perfect square, like I could say the square root of 9 is 3. But if I give you the square root of a number that's not a perfect square, like 10, okay, the square root of 10 is a decimal that goes on forever. So that is also considered irrational. So I can say the square root of 10, the square root of 2, etc. All right, so it breaks down into these two categories. If your number is real and irrational, that's it. That's all the farther it gets broken down. But if your number is real and rational, it's kind of like a flow chart and it keeps going. There are different ways to categorize our numbers. So the next group that we're going to have is basically a branch off of your rational numbers. And what we're going to do is basically get rid of a group of these and call it something else. So the next thing that leaves this group is the fractions and the decimals. We're going to get rid of fractions and decimals and call it a new group of numbers. And we're going to call it the integers. So our next group of numbers, the integers. This includes your positives, your negatives, and 0. There are no decimals and no fractions. Okay? So this includes examples like -3, -2, -1, 0, 1, 2, 3, and so forth, okay? No decimals, no fractions, these are called your integers. Next, this group of integers is going to get broken down into a separate category, and we're going to get rid of something from this group and call it something else. What do you think we're going to get rid of? The negatives. So getting rid of the negatives creates a second group, or another subgroup called the whole numbers. So negative numbers are not whole numbers. So your whole numbers are just positives and 0. Which means no decimals, no fractions, and no negatives. Which gives us a list of examples starting with 0, 1, 2, 3, 4, okay? 0 and your positive numbers. This group gets broken down into one more subgroup. The only thing really for us left to get rid of is 0. So when we cut 0 out of this group, we now have a subgroup called the natural numbers. And the natural numbers are just your positives, which these are also known as your counting numbers. So maybe when you were little and when you first started counting, you started with 1, right? If I ever do have children, I'll probably start them out with 0. We'll start with those whole numbers. All right, so no decimals. No fractions. No negatives. And no 0. So you just start with 1, 2, 3, 4, 5, etc. Okay? There are your list of subset numbers. So basically, if I give you a number like 5, Okay, that is a natural number. 5 is also a whole number. It's also an integer, and it's also rational, and it's also real. So if you have a number later on in the flow chart, it's also everything above. Again, if you have an irrational number like pi, it's irrational and it's real. So all of these numbers that I've talked about are still all real. If I have an integer, the integer is also rational and it's also real, but it is not whole and it is not natural, okay? So the flow chart only works up. So if I have a whole number, it's whole, an integer, rational, and real. Again, they're all real. So you should know that going into the next set of lessons. There's also a shorthand, an abbreviation that we use for these. So if we're talking about real numbers, let me use purple. The shorthand for real numbers isn't a fancy R. It's just got 2 lines to it. So we talk about real numbers. If you wanted to abbreviate, like if I ask you to list out what type of number is, you can use the fancy R to say that it's real. Okay, rational, since we already used an R, it only makes sense that to abbreviate rational, we use Q. Rational. It's a rational number. There's a Q in there somewhere. An irrational number, we abbreviate that with a capital I. Capital I, that's important, because the lowercase I stands for your imaginary number. And if you remember at the beginning, I said you have 2 types of numbers, real and imaginary. But we're not really going to discuss imaginary yet. Maybe once we get to chapter 9. Your integers, the abbreviation for integers is a Z. Because obviously, I was already taken for irrational, so we had to get creative and use a different letter to describe integers. Whole numbers, W, and natural numbers, N. Okay? So those are different ways that you can abbreviate the different categories of a number. And when we return to school, the next part of our notes, the examples, we'll have to list what type a number is. So if we look at like A, example 3A, we've got the number -1/3. That would fall in the category of being a fraction. So it's rational and real. You could say Q and fancy R, and then that would describe the different categories that that number falls into. All right, that's all for today. Enjoy.